Hello, my name is Igor and welcome to my Tech One. And it looks like I am under the Ender3 invasion because few weeks ago I did a review of Ender3 S1 and now this is Ender3-V2 Neo. And in few weeks the Ender3 S1 Pro is arriving, and this Ender3-V2 Neo is sent to me by Creality 3D Official in exchange for a review. Now this should be some kind of improved Ender3-V2. And I was a little bit confused, so why they launch this kind of printer when they have S1. And I really like the sentence I got. It says, overall Ender3-V2 Neo probably gets C as a new Creality 3D printer, but earns A as a renewed Ender3-V2, because it will contain all those essential upgrades which usually users install on Ender3-V2. And now let's see what are those upgrades. CA Touch auto leveling sensor, which makes the life so much easier when we want to print something. PC Spring steel magnetic build plate, that's the official name. So some kind of flexible sheet, and with this the removing of the object is much easier because we can just bend a little bit that surface and it's easier to remove the objects. We don't have to use the spatula like on the glass, and because it can run and cut ourselves as similar. Stronger yellow springs, they hold the position of the bed much longer, and with this we don't have to do the manual bed leveling so often. Yes, you heard good, it has the auto leveling sensor, but even then it is important, you will see later, to do the manual bed leveling first to make the surface parallel with the moving pad of the nozzle as much as possible. In that case, less has to be compensated by that information collected by the auto leveling sensor. And it's easy to assemble because I checked my review video of Ender3-V2. There it arrived in a lot of pieces, and here it should be quite pre-installed, so the assembling should be much easier. And it also has the metal bowden extruder because yes, on Ender3-V2 it was plastic, and after a few months of using, very often that it broke and the user has to replace to metallic anyway. So let's see what's in the box, assemble it and do some test printings. User manual. This is the screen with this rotating button. And this is the content of the bag, so we have the pliers, don't forget, this is the needle for the cleaning of the nozzle, screwdriver, Allen keys, operand wrenches, spare nozzle and connections for the Bowden tube, bolts for assembling, SD card with USB adapter, some zip ties, knob for the extruder, and sample filaments which unfortunately are not on the spool. Scraper or spatula, the power cable, the spool holder. This is that whole bridge Z-axis with Ender3 completely assembled, and it's connected with the base with the cable. Oh, and the box is empty. But definitely the assembling will be super easy compared to the regular Ender3-V2. The first step is installing the gentle frame. 2 bolts from each side, but to make it simpler you don't have to rotate it, just move it to the side of the desk and you can do it from the bottom. Next is installing the display to the right side of the printer, but for this first I will remove it from the holder. Then I have to align these T-nuts to be parallel with each other and this slot. And when I tie these bolts, the T-nuts will rotate 90 degrees and lock the position. I can install the cable now. And now installing the spool holder, I lose these T-nuts and again I align them to be in a line, in a slot, and I will move them as much as possible to the left side because the path of the filament will be here into extruder. Placing the indicator knob on the extruder, and I have to align this flat surface. Next step will be the wiring, but before that I want to check the tension on the timing belt and the V-slot wheels. In my case, the x-axis is tied correctly. On z-axis. On this side, yes, but on this side, no. I hope you can see that I can rotate these wheels very easily with my hand. So I have to tighten it, but not on this side. But here there is an eccentric nut, and I have to use the open-end wrench to make a tension with this wheel. Okay, this is very important because this has only single z-axis. On this side, this X-joint is hanging in the air. So it is basically supported only by these three wheels. And wheels on y-axis has to be tightened too. It looks tight now. I cannot rotate the wheels with my hand, so I think the y-axis is ready too. And now the tension on the timing belts, it looks like it is set correctly. But if you need to tighten it, you can rotate these two knobs, but be careful because you can easily over tighten it with this mechanism. Now it is extremely important to check this switch here on the back side of the printer. This is the voltage. In Europe it is set correctly now to 30 volts. In US you have to switch it to 115 volts, for example. Interesting solution for this sear touch bracket. First I thought it is bended, but this is on purpose because this hot end fan will get the air for the cooling. And now the wiring, it is easy because the wires are marked. I'm starting with the Z-axis stepper motor. The next would be the Z-axis limit switch, but we don't have it because we have the auto leveling sensor. E is extruder stepper motor, is this one next to the lead screw. X, the bigger one, is for the X stepper motor. And the smaller X, it is for the limit switch. It's from the bottom, a little bit hardly visible. Let's do some cable management with these zip ties. Basically our other wires are already connected, but before I connect the power supply cable, I want to take a quick look what is inside. So this is the power supply unit inside, and this is the ventilation hole for the fan. And it looks like they did the same mistake like with Ender3-V2, because here we have again a ventilation holes where the air will exit. I have a link which I did very important safety upgrades on Ender3-V2. I will place a link down in the description. And this is the toolbox. And here is the main board unit. So I have to remove these three bolts and one from the top side, and then I can remove this plate. One bolt from the top and three from the bottom. The fan is connected to the main board. Well, it looks like absolutely no changes here. This is 4.2.2 board with a lot of hot glue. And these are high current wires, and as you can see there are no ferrules on them, so they are tinned and tight in these terminals. So definitely I would suggest you to take my video about Ender3-V2 safety upgrades. I can place back this plate, only I have to pay attention not to pinch here these cables. These cut and alloy extrusions are very sharp. And now I can connect the power cable and start with the leveling process. Ah yes, very important step. And now power on. For the first feeling it is not so loud like Ender3-V2, but when I start with the printing, only then will the power supply unit turn on. But before I start with the first homing, I want to compress a little bit these springs because they are completely loose. These springs, yes, they are yellow, which is very often suggested upgrade on Ender3-V2, but for the filling definitely they are not so strong like those really yellow springs. And now I can do the first auto home. It's home now, but it always lifts the Z-axis a little bit, so I will now move the Z-axis to 0 position. Okay, so it is now on 0 on the Z, and now I can move the Z offset, that 0, to be exactly on the top of this paper. I'm disabling the stepper motors, and now I will move it to these corners and adjust the manual bed leveling with these knobs. This is important. With this I will make this surface parallel to the moving pad of the nozzle. If I do this correctly, basically the auto bed leveling sensor don't have to compensate anything at all during the printing. One last check in the middle. Okay. One more time I will auto home and check the Z offset. And now I will start the leveling process, and then the auto leveling sensor will record the distance from the several points, and that will be compensated during the printing. And now I can preheat the hot end and insert this sample filament and do some test printing. Preheating the PLA. Now be very careful with this kind of sample filaments because it can easily fall from the spool holder or maybe jam or something like that. So always supervise the printing if you are using these sample filaments. Cut the end under 45-degree angle. Just to show you, press this and insert the filament. Looks like some black filament was tested before, so I have to extrude it until it's clean. Now let's print something from the SD card, and I always suggest to print something what is prepared by the manufacturer. If there is any problem, you know that is not case by the slicer. Print. I don't have any information about this, so let's watch one. Ah, it's a Benchy, okay. The printing started, but I was ready to go into tune and set the Z offset if necessary, but it looks like everything is okay, so I didn't change anything here. And I really have to supervise it because I can easily have a filament jam when it's not on the spool. Let the first layer lay down correctly. On blue knob you can see the retraction. The printing is finished, and immediately I want to check the bed adhesion, which is great, and I'm already familiar with this type of the surface, so I know it's not a problem. But I will wait until it cools down a little bit and then I will try to remove it. Oops. Well, the skirt also stick too good to the bed, so probably I will raise a little bit the Z offset, but now let's analyze the Benchy. Basically this Benchy came out great on the first look, but only I can see a little bit more stringing than I would like to see with the PLA. The bridging and overhang is okay, a little bit dirty first layer because previously it was the black filament inside. And interesting, this letter should be inside a little bit, so it should start with a small hole, but here I cannot see that, so somehow this doesn't look like an original Benchy, at least this first layer. Otherwise quite acceptable, but now I will prepare the slicer and create my own G-code. I'm adding the printer to Ultimaker Cura, add new printer, non-network printer. I'm searching for Creality folder, and only I have here Ender3 Pro, but it has the same dimensions. I'm only renaming it, but everything else, the dimensions are the same. And then I can insert a calibration cube, slice it, and copy to SD card. The G-code is on SD card, and let's print that calibration cube. Don't forget to keep this surface clean. I'm cleaning it with isopropyl alcohol. Print XYZ calibration cube. And since the Benchy stick too good to this surface, I will raise a little bit the Z offset. Now this time it came down more easier. And this surface looks great in Z, X and Y direction. Of course here we don't have that stringing because it is one piece object. And let's check the dimensional accuracy. This is in X direction. Y direction and Z direction. A little bit smaller than it should be, but quite acceptable. With my next printing I want to check the bed leveling. I'm printing these small squares which are spread all over the bed, and I can see the first layers are very equal, so it looks like the auto bed leveling sensor works good and the bed is leveled. Printing is finished without any problems, only I can see a few strings here when it moved from one object to the other, but everything else is perfect, so the bed is leveled. My next test object is a cylinder, which I actually need for one of my projects. Actually, cylindrical surfaces are good to detect if there is any problem along the z-axis. For example, if you can see some waves with the size of 8 mm, which is actually the pitch size of the lead screw, then we know that we have some problems. But so far this looks very clean, but I will analyze it when it's finished. The printing is almost finished, it's covering the top surface now. Let's take a quick look. And this is also great surface, so there are no signs of the vase and the seams are hardly visible. This will be some kind of cups for one of my future projects, some kind of antibacterial testing, so that's why I use the gloves with these objects. And printing is finished. And they look great actually, since of course they are visible here on the back side, but everything else is okay. And interesting, this time I couldn't see that extra stringing. I printed these minis for my daughter when I was experimenting with these filaments, and now she asked for one more, for a bigger one, because they need a teacher, and I will print it with this silver golden filament. The printing is only at 15%, and actually I'm starting to like these tree supports. And what I'm curious about this printing is that if the color orientation will be constant or the filament will be twisted during the printing. And the printing is finished in exactly 5.5 hours, and interesting that I don't see any more that stringing here, which I saw on the Benchy, so this means that was the result of the cheap filament. This is good quality and dry filament, and I got a very nice smooth surface. Let's remove those supports. Very nice and smooth surface, and the filament is not twisted, so from this side it is silver and from this side it is golden color. This is from my previous video, printed in a vase mode, and my wife really liked it and asked for something similar but bigger. So my last testing for this video will be printing something in a spiral mode, a vase, and it will be 200 mm tall. Something is wrong with this printing, because this should be a continuous spiral path, but I can see that approximately after a quarter circle it stops for the moment. So I'm definitely confused here. When it stopped for a moment, then because of the oozing from the nozzle, it creates some small spot. And repeating this every maybe quarter of the circle results this line from these spots around the object, which doesn't look bad, but it is not part of the design. In the meantime, I got the answer in the Facebook group. So the power loss function is on, and this results this small break. So I will stop this printing, and I will disable this function, and I will repeat this, and I'll see the difference. And the problem is solved. So I added this command at the beginning of the gcode, and with this I disabled the power loss resum function, and now the printing is completely smooth without those breaks in the printing. Good morning, and it's finished. So blue from this side, theoretically red, but it's some kind of purple from the other side. but the transition is not so smooth. I can see some lines here, so this means the filament was a little bit twisted during the printing. But anyway, this vase looks great, and especially if I compare with this one, it is completely smooth. We don't have those spots anymore. So if you want to print in vase mode, then you have to disable the power of resume function. And now I want to measure the noise with the sound level meter, and the distance from the hot end is exactly half meters. And now I'll be quiet and to measure the value. Approximately 53 decibels. And I will add this to my website into the table with the other results. Another conclusions. Well, Ender3-V2 Neo is very nicely upgraded V2. But I would like to see maybe two more important upgrades, like, I don't know, ferrous and high current wires, or maybe a little bit stronger springs. I believe they added these upgrades to existing V2s or maybe to existing production line. And the reason you want to buy the V2 Neo will be the price. It should be a little bit below $300. And actually, if you don't need a direct extruder, for example, you don't want to print TPU, in that case, V2 Neo is a great and affordable alternative to S1. And what's your opinion about V2 Neo? You can write me something down in the comment section. Thank you for watching and happy printing!